In just the last few billion years, Earth has been battered by space rocks, frozen into a snowball, blasted by volcanoes, and nearly destroyed multiple times. Entire continents vanished. Species rose and fell. Dinosaurs ruled, then disappeared. And yet, here we are. How did our planet survive all this chaos? Let's rewind time. About 4.5 billion years ago, long before there were oceans, mountains, or even a moon, our story began in a violent nursery of stars. The solar system was born from a colossal cloud of interstellar dust and gas. Gravity pulled everything inward, heating it up until, boom, the sun ignited into a massive ball of burning hydrogen. Around this newborn star, the leftover debris began to clump together, forming the seeds of planets. In the inner part of this swirling disk, rocky materials collided and fused. Among these collisions, a molten, chaotic ball of rock formed, the early Earth. It had no oceans, no breathable air, just fire, fury, and the building blocks of everything to come. As gravity held this ball of magma together, its surface slowly began to differentiate. Heavy metals sank to the core, forming a spinning dynamo that would one day create Earth's magnetic field, shielding it from solar radiation. Meanwhile, lighter silicates floated upward, forming the planet's crust. But Earth's formation wasn't finished. A few 100 million years in, disaster struck. A Mars-sized body named Theia slammed into Earth. The collision was so violent it nearly shattered our young planet. But it also gifted us the moon. Debris from the crash was pulled into orbit and eventually molded into our lunar companion, a stabilizing force that would one day help life thrive. Without the moon, tides wouldn't exist the way they do. Earth's spin would wobble wildly. This cosmic accident may have made life possible. In fact, the moon plays a key role in regulating Earth's tilt, which helps create the seasons. And tides driven by the moon may have been essential for stirring early oceans, allowing chemical reactions to take place. Early Earth wasn't just hot, it was hostile. Volcanoes choked the sky with toxic gases, hydrogen sulfide, methane, carbon dioxide. There was no oxygen, no protective ozone layer. Asteroids and comets frequently slammed into the surface, sometimes bringing ingredients like water, carbon, and amino acids. Eventually, Earth began to cool. Around 3.8 billion years ago, something miraculous happened. Steam in the atmosphere condensed into liquid. Rain fell for centuries, forming vast, steaming oceans. The water was acidic, bubbling with volcanic chemicals, but it was water nonetheless. And water is life's favorite canvas. In these primal seas, energy from geothermal vents, lightning, and sunlight likely triggered a chain of chemical reactions that would lead to the first living cells. Somewhere in those dark, mineral-rich oceans, life sparked. The first life forms were simple, single-celled organisms, tiny bubbles of chemistry that could reproduce, feed, and evolve. These microbes were the only residents of Earth for over 1 billion years. And even though they were invisible to the naked eye, they were doing something revolutionary. Then came cyanobacteria. These microscopic organisms learned to harness sunlight through photosynthesis. And in doing so, they released a waste product that would change the world forever: oxygen. This process transformed Earth's atmosphere, paving the way for future life, but not without consequences. Around 2.4 billion years ago, The great oxygenation event began. Oxygen flooded the atmosphere, but instead of creating paradise, it caused catastrophe. Oxygen reacted with methane, a powerful greenhouse gas, cooling the planet dramatically. Earth plunged into its first global ice age. For millions of years, glaciers may have covered nearly the entire surface, but life adapted. Extremophile organisms survived in hydrothermal vents beneath the ice. And when the ice receded, something astonishing happened. Oxygen not only made respiration more efficient, it laid the groundwork for complex multicellular life. But first, Earth had to go through tectonic turmoil. Continents began to rise from the oceans as floating plates of crust moved atop Earth's molten mantle. The first small land masses eventually collided to form Valbera, then later Rodinia, one of the greatest supercontinents in Earth's history. Then came Pannotia. But as continents shifted, so did evolution. About 540 million years ago, the Cambrian explosion occurred, a relatively short burst of time when complex life erupted in the oceans. Animals with shells, spines, eyes, and even brains evolved. Trilobites scuttled along the seafloor, and ecosystems as we know them began to form. It was life, turned up to 11. Predators emerged, nervous systems advanced. The arms race of evolution had officially begun. But evolution isn't a straight path. It's a roller coaster. Roughly 440 million years ago, Earth's first mass extinction wiped out much of this new life due to shifting climates and dropping ocean temperatures. More extinctions followed over the next hundreds of millions of years, each one devastating, but each one also clearing the way for new life to flourish. Trees appeared, insects took flight, fish walked onto land, amphibians evolved, reptiles emerged. Life was expanding, but doom was always around the corner. Then came Pangaea, the ultimate supercontinent that would both unite and doom life once again. Around 250 million years ago, Earth's landmass formed one giant continent, Pangaea. But with this unity came destruction. Volcanic eruptions and greenhouse gases triggered the Great Dying, the worst extinction event ever. 90% of life vanished. Then the survivors evolved again. Among them, dinosaurs. For 150 million years, these majestic creatures ruled the Earth. From the towering Argentinosaurus to the terrifying T-Rex, they filled every corner of the planet. Birds took to the skies, flowering plants emerged. The world was lush, vibrant, and doomed once again. 66 million years ago, a 6-mile-wide asteroid struck what is now Mexico. It triggered fires, earthquakes, tsunamis, and global darkness. The dinosaurs never saw it coming. Within years, they were gone. But in their absence, a new lineage had its chance. With the dinosaurs gone, mammals began their quiet rise. Small, warm-blooded, and adaptable, they began to evolve into new forms. One lineage led to primates, and eventually, to us. 6 million years ago, Sahelanthropus, one of the earliest human ancestors, appeared. Still partly walking on all fours, these beings began the slow climb toward what we now call humanity. By 4 million years ago, early hominins walked upright. 3 million years ago, they made tools. 800,000 years ago, they controlled fire. Fire was a revolution. It meant warmth, protection, and cooked food. And it allowed our ancestors to explore the unknown. Then came Homo sapiens, us. By 40,000 years ago, we were the last humans standing. With language, culture, and art, Homo sapiens spread across the globe. We painted caves, buried our dead, and mapped the stars. Civilization had begun. 10,000 years ago, humans discovered agriculture. We stopped wandering and built villages, cities, empires. We built pyramids, wrote poetry, flew to the moon. But in the last 250 years, we've changed the Earth more than anything before. The Industrial Revolution supercharged technology, cities, and our population. From 1 billion in 1804 to 8+ billion today, humans now influence nearly every part of the biosphere. We've mined mountains, dammed rivers, reshaped coastlines, and launched satellites into orbit. We have the power to transform the planet and the responsibility to protect it. But this power comes at a cost. Climate change, rising seas, habitat loss, mass extinctions, we're now facing a crisis of our own making. Biodiversity is declining, extreme weather is rising, coral reefs are bleaching, forests are vanishing. If we don't change course, we could become the architects of Earth's next great extinction. But unlike any species before us, we know what's happening. We have the science, we have the tools, and perhaps we still have time. The question is, what will we do with it? So next time you walk outside and feel the wind or touch the soil, remember, you're standing on the surface of a survivor, a world that has lived through fire and ice, silence and explosion, extinction and rebirth. But its story isn't finished. We are the next chapter. What happens next? That's up to us. Want to know what Earth might look like 100 million years from now? Or what would happen if we never existed at all? Click on the next video from the vast unknown and let's explore what's still to come.